Hello students and welcome to Math Weekly number 14. Our focus skill in this Math Weekly will be comparing the y-intercepts of two related relationships. Before we begin looking at that focus skill, let's look at some y-intercepts basics that were reviewed in Math Weekly number 13. Remember, in a relationship, the x value is the set of all the inputs, whereas the y value is the set of all outputs. By definition, a y-intercept is the situation in which the x is 0. We also learned in Math Weekly number 13 that to determine the y-intercept depends on which representation you're given. We learned that if we're looking at a real-world situation, we look for initial values, flat rate charges, base fees, supply costs, etc. If looking at a table of values, we look for the ordered pair in which the x value is 0, something like 0, 5. If necessary, we sometimes have to extend the table to include an ordered pair in which the x value is 0. The third relationship that we looked at was on a coordinate plane. And when we look at a coordinate plane, we're looking for where the graph crosses the y-axis. If as an equation, after getting this equation into slope-intercept form, which is y equals mx plus b, look for the constant in the b's location. That constant is the y-intercept. And remember, this can be a positive value or a negative value. If you do not know how to do these four skills, rewatch Math Weekly number 13's video, because from here on out in this video, I'm assuming that you've mastered those skills. So our new skill is comparing the y-intercepts of two related relationships. To do so, first, determine the y-intercept of the first situation. Second, determine the y-intercept of the second situation. And then third, compare the two y-intercepts in context to how the two situations are related. So let's look at an example. Mrs. Martin is in need of a plumber to run some pipes for her new house. There are two certified plumbers in the area, Fancy Yancey's Plumbing and TR Plumbing. Both businesses charge the same amount per hour for labor, but a different charge for materials. Fancy Yancey's Plumbing charges customers a total charge Y based on the number of hours worked X according to the relationship to the equation Y equals 50X plus 100. TR Plumbing charges customers according to the relationship depicted in the chart below, with X representing the number of hours worked and Y representing the total charge for a customer's bill. Which plumbing company charges the lowest charge for materials? The materials would be a flat rate charge, and that's why this is considered a y-intercept problem. So we're given the relationship in three different ways in this. We're looking at a real-world situation, but the one relationship is given to us as an equation, and the other is given to us as a table. So let's begin with the equation for Fancy Yancey's. Remember, when we're looking for the y-intercept given an equation, we need to make sure it's in slope-intercept form, meaning the y is all alone, and it is. And our flat rate charge will be what's being added or subtracted to the variable. So it's adding 100. So that means that Fancy Yancey's charges $100 for materials. I'm just making myself a little note right there. Now I can eliminate thinking about that equation. I now know Fancy Yancey's charges $100 for materials. Now, the second representation that I'm given, so this is step 2, is a table. We need to extend this table backwards to include the point 0 for 0 hours worked, because if we take out the fees for the hours worked, we'll know how much the materials are. So you can see that this table is counting up by 3s. We need to count down by 3. 3 minus 3 makes 0. So if it goes up by 150 in 3 hours, it would go down by 150 in 3 hours. So if we take 200, take away 150, we get $50 left. So TR Plumbing charges $50 for materials. And our last step is to look at the two of these in context to the problem, which we're talking about the lowest charge for materials, and make a conclusion. In this case, our conclusion would be TR Plumbing charges less for materials than Fancy Yancey's Plumbing. And you can see they charge $50 less. Let's look at one more example. Aaron is researching cell phone companies. There are two companies in his area that provide cell phone service, Company S and Company T. Both companies charge their customers a flat rate monthly charge. So when we hear flat rate, that's the Y-intercept that we're looking for. Flat rate monthly charge and a certain amount of money per minute the cell phone is in use. The charges for both companies are graphed on the coordinate plane below. Identify the Y-intercepts for both. Now, this example combines two of the four ways a y-intercept can be depicted. We have a real-world situation here, and we have a coordinate plane. Remember, on a coordinate plane, the y-intercept is where it crosses the y-axis. So here is the y-axis. The line for company T is touching the y-axis at $5. That means T charges a $5 monthly charge. Look at company S's line. It touches the y-intercept or the y-axis at 15. So company S charges $15 as a monthly charge. Now that we've came up with the y-intercepts for each one, we can state a conclusion. Our conclusion is Company S charges $10 more than Company T as their flat rate monthly charge. So to summarize what we've learned, as we've learned to compare the y-intercepts, there are 3 steps to comparing two y-intercepts. First, determine the y-intercept of the first situation. Step 2, determine the y-intercept of the second. And step 3, compare the two y-intercepts in context to how the two situations are related.